In this video, I shall present part 3 of test 11. Exercise number 1. In the figure below, it is represented a rectangle ABCD with AB equals 60 centimeters and BC equals 50 centimeters. The squares AEFG and CHIJ have the side equal to 10 centimeters. Point A. Determine the shaded surface area. Point B. Prove that if M is the middle of the AB segment, then the lines FM and IM are perpendicular. Point C. Prove that EH, FI, and GJ lines are intersecting. Point A. The shaded surface area is equal to the surface area of the rectangle ABCD minus the sum of the surface areas of AEFG and CHIJ squares. So the surface area of the rectangle ABCD is equal to AB times BC, which is equal to 60 times 50, which is equal to 3000 square centimeters. The surface area of the squares AEFG and CHIJ is equal to 10 to the power of 2, which is equal to 100 square centimeters. So the shaded surface area is equal to 3000 minus 100 plus 100, which is equal to 2800 squared centimeters. Point B. Point M is the middle of the segment AB. So from this we have that the segments AM and MB are congruent. So AM is equal to MB, which is equal to 30. AM is equal to AE plus EM. So EM is equal to AM minus AE, which is equal to 30 minus 10, which is equal to 20. BM is equal to BN plus MN. So MN is equal to BM minus BN. The segment IJ is congruent to the segment NB, so IJ is equal to NB, which is equal to 10. MN is equal to 30 minus 10, which is equal to 20. CB is equal to CJ plus JB, so JB is equal to CB minus CJ, which is equal to 50 minus 10, which is equal to 40. The segment JB is congruent with the segment IN, so IN is equal to JB, which is equal to 40. From the right triangle FEM, we have with Pythagoras' theorem that FM squared is equal to FE squared plus EM squared. So FM squared is equal to 10 to the power of 2 plus 20 to the power of 2, which is equal to 100 plus 400, which is equal to 500. So FM is equal to the square root of 500, which is equal to 10 times square root of 5. From the right triangle INM, we have with Pythagoras' theorem that IM squared is equal to IN squared plus MN squared, which is equal to 40 to the power of 2 plus 20 to the power of 2, which is equal to 1600 plus 400, which is equal to 2000. So IM is equal to the square root of 2000, which is equal to 20 times square root of 5. We have that FNEP is a rectangle, so the segment FP is congruent to the segment EN. So FP is equal to EN, which is equal to 40. The segment FE is congruent to the segment PN, so FE is equal to PN, which is equal to 10. IN is equal to IP plus PN. IP is equal to IN minus PN, which is equal to 40 minus 10, which is equal to 30. From the right triangle IPF, we have with Pythagoras theorem that IF squared equals IP squared plus PF squared, which is equivalent to IF squared is equal to 30 squared plus 40 squared, which is equal to 900 plus 1600, which is equal to 2500. So EF is equal to the square root of 2500, which is equal to 50. IF squared is equal to IM squared plus FM squared, which is equivalent to 50 squared is equal to 10 square root of 5 everything squared plus 20 square root of 5 everything squared. So 2500 is equal to 500 plus 2000. So 2500 is equal to 2500, which is true. So we have from the reciprocal of Pythagoras theorem that the triangle IMF has a right angle in M. So the measure of the IMF angle is equal to 90 degrees. So IM is perpendicular on FM. Point C. We can see from the figure drawn that EH intersected with FI is different from the void set. The same goes for GA intersected with FI and EH intersected with GJ. So from these three statements results that EH, FI and GJ lines are intersecting. Problem number 2. In the figure below it is represented a regular square prism ABCD, A prime, B prime, C prime, D prime, with the side of the base AB is equal to 4 meters and the lateral side AA prime is equal to 2 square root of 2 meters. Point A. Calculate the volume of the prism in cubic meters. Point B. Determine the sine of the angle between the lines A'C and AD. Point C. Prove that the planes A'BD and C'BD are perpendicular. Point A. The volume of the prism ABCD, A prime, B prime, C prime, D prime is equal to the surface area of base ABCD times the height of the prism, which is equal to AB times BC times AA prime, which is equal to 4 times 4 times 2 square root of 2, which is equal to 32 square root of 2 cubic meters. Point B. AD line is parallel to BC line, so the sine of the A prime C, the sine of the angle between A prime C and AD lines is equal to the sine between AC and BC lines, which is equal to the sine of the angle A prime CB, which is equal to A prime B over A prime C. From the right triangle A prime AB, we have with Pythagoras theorem that A prime B squared is equal to A prime A squared plus AB squared. So A prime B squared is equal to 2 square root of 2 everything squared plus 4 squared, which is equal to 8 plus 16, which is equal to 24. So a prime b is equal to the square root of 24, which is equal to 2 square root of 6. From the right triangle a prime bc, we have with Pythagoras theorem that a prime c squared is equal to a prime b squared plus bc squared. So this is equivalent to a prime c squared is equal to 2 square root of 6 everything squared plus 4 squared, which is equal to 24 plus 16, which is equal to 40. A prime c is equal to the square root of 40, which is equal to 2 square root of 10. The sine of the angle A prime CB is equal to 2 square root of 6 divided by 2 square root of 10, which is equal to square root of 6 over square root of 10, which is equal to the square root of 6 over 10, which is equal to the square root of 3 over 5, which is equal to the square root of 3 times square root of 5 of everything over 5, which is equal to the square root of 15 over 5. Point C. The segment A prime D is congruent to the segment A prime B, so we have that the A prime BD triangle is isosceles. The segment C prime D is congruent to the segment C prime B, so the triangle C prime BD is isosceles. BD's segment is common side. We mark this statement with 1. The segment A prime D is congruent to the segment A prime B, which is congruent to the segment C prime D, which is congruent to the segment C prime B. We mark this statement with 2. From the statements 1 and 2, we have from the criterion side that the triangle A prime BD is congruent to the triangle C prime BD. From the right triangle C prime OB, we have with Pythagoras theorem that C prime B squared is equal to C prime O squared plus OB squared. So C prime O squared is equal to C prime B squared minus OB squared. So C prime O squared is equal to 24 minus 8, which is equal to 16. So C prime O is equal to square root of 16, which is equal to 4. From the right triangle A prime OB, we have with Pythagoras theorem that A prime B squared is equal to A prime O squared plus OB squared. So A prime O squared is equal to A prime B squared minus OB squared, which is equal to 24 minus 8, which is equal to 16. So A prime O squared is A prime O is equal to the square root of 16, which is equal to 4. A prime B squared minus OB squared is equal to 24 minus 8, which is equal to 16. So AO squared is equal to square root of 16, which is equal to 4. A prime C squared is equal to A prime O squared plus C prime O squared. This is equivalent to 4 square root of 2 everything squared is equal to 4 squared plus 4 squared. So 16 times 2 is equal to 16 plus 16. So this is equivalent to 32 is equal to 32, which is true. So we have from the reciprocal of Pythagoras theorem that the A prime OC prime triangle has a right angle in O. So the measure of the angle A prime OC prime is 90 degrees. The measure of the angle between planes A'BD and C'BD is equal to the measure of the angle between the lines A'O and C'O, which is equal to the measure of the angle A'OC', which is equal to 90 degrees. From this results that the planes A'BD and C'BD are perpendicular. This was the third part of test 11. Thank you for your attention. Goodbye.